Matter is everything around you. Air, water, your phone, even your frustration right now. All of it is made of particles, and those particles behave in ways that explain why materials look and act the way they do. To understand chemistry properly, you need to understand how particles behave in different states and how energy changes everything. There are three main states of matter: solid, liquid, and gas. The difference between them is not what they are made of, but how their particles are arranged, how much they move, and how strongly they attract each other. In a solid, particles are packed very close together in a fixed, regular arrangement. You can imagine them like people standing shoulder to shoulder in a crowded elevator with no room to move. They cannot move from place to place, but they are not completely still. They vibrate in their positions. The forces between them are strong, which is why solids keep a definite shape and volume. If you heat a solid, the particles gain energy and vibrate more strongly. This causes the solid to expand slightly because the particles push a little further apart. Question: why do solids keep their shape? Because the particles are held in fixed positions by strong forces and cannot move freely. In a liquid, the situation becomes more relaxed. The particles are still close together, but they are not fixed. They can move past each other. Think of people in a crowded room who can slowly walk around each other. The forces between particles are weaker than in solids, which allows movement but still strong enough to keep them close.
Liquids have a fixed volume but no fixed shape.
They flow and take the shape of their container. Question: why can liquids flow but solids cannot? Because the particles in liquids can move past each other while particles in solids are fixed in place. In a gas, everything becomes chaotic. The particles are far apart, with almost no forces holding them together. They move freely and rapidly in all directions. Most of the space in a gas is actually empty.
Gas particles move in straight lines until they collide with each other or the walls of a container.
Gases do not have a fixed shape or volume and will always expand to fill any space available. Question:
why do gases fill any container?
Because their particles move freely in all directions and are far apart with very weak forces between them. Temperature plays a huge role in all of this. When you heat a substance, you are giving energy to its particles. More energy means more movement. In solids, this means stronger vibrations. In liquids and gases, it means faster movement. In gases, faster particles hit the container walls harder and more often, which increases pressure. Now, this whole explanation is based on something called the particle theory model. It is a simplified way to imagine how particles behave. It treats particles like tiny solid spheres. This helps us understand behavior, but it is not perfectly accurate. Real particles are atoms, ions, or molecules, not little hard balls. The model also does not show the forces between particles clearly, and it does not show correct sizes or distances. Question: give one limitation of the particle model. It does not accurately show the forces between particles. Another important idea is the difference between bulk properties and individual particles. When you measure something like melting point or density, you are measuring the behavior of a huge number of particles together. A single atom does not have a melting point. These properties only make sense when many particles interact. Now let's talk about changes of state, which is where things actually get interesting. Substances are not stuck as solids, liquids, or gases forever. Change the temperature and you change the state. When a solid is heated, its particles gain energy and vibrate more. Eventually, they have enough energy to break free from their fixed positions. At this point, the solid melts and becomes a liquid. The temperature at which this happens is called the melting point. Question: what is melting? It is the change from solid to liquid when particles gain enough energy to move freely. If you keep heating the liquid, the particles gain even more energy. They move faster and eventually overcome the forces holding them together completely. At this point, the liquid boils and becomes a gas. This happens at the boiling point. Question: what is boiling? It is the change from liquid to gas when particles have enough energy to completely overcome attractive forces. Cooling works in reverse. When a gas loses energy, the particles slow down. Eventually, they no longer have enough energy to stay far apart, so they come closer together and form a liquid. This is condensation. Question: what is condensation? It is the change from gas to liquid when particles lose energy and come closer together. If a liquid keeps losing energy, the particles slow down even more until they cannot move past each other anymore. They become fixed in place again, forming a solid. This is freezing. Question: what is freezing?
It is the change from liquid to solid when particles lose energy and become fixed in position.
These changes are physical changes.
This means the substance itself does not change into something new.
Only the arrangement and movement of particles changes. Now here is where you stop memorizing and start actually thinking. The melting point and boiling point of a substance depend on how strong the forces between its particles are. Strong forces need more energy to break, so the substance will have high melting and boiling points. Weak forces need less energy, so the substance will melt or boil easily. Question: why do some substances have high melting points? Because they have strong forces between particles that require a lot of energy to overcome. You also need to be able to predict the state of a substance at a certain temperature. This is just logic, not magic. If the temperature is below the melting point, the substance is a solid. If it is above the boiling point, it is a gas. If it is between the two, it is a liquid. Question. Ethanol melts at -114 degrees and boils at 78 degrees. What is its state at -150 degrees? Solid. Question.
What is its state at 25 degrees?
Liquid. Question. What is its state at 100 degrees?
Gas.
Finally, state symbols are used in chemical equations to show the physical state of each substance. Solid is written as S, liquid as L, gas as G, and aqueous as AQ. Aqueous means dissolved in water. Question. What does aqueous mean? It means the substance is dissolved in water. Question.
Write the correct state symbols for this reaction. Iron reacts with hydrochloric acid to form iron chloride and hydrogen. Fe plus 2HCl AQ forms FeCl2 AQ plus H2G.